I wanted to start off with, I don't know if Jerry Glynn is in the audience here or not. Stick your hand up if you are. Yeah, there you are. So he said something to me very interesting, I thought, many, many years ago when I'd sort of shown him some of the amazing things that Mathematica could do. And he said, well, if this is so great, why are you selling this to people? Why don't you keep it for yourselves and do something with it that nobody else can do and make a lot of money? You know, what a waste to let other people have access to this amazing thing. And I thought that was a very insightful comment that was not compatible with our business model at the time. Anyway, so we spent 20 years selling this tool to other people, but after 20 years, it sort of kind of happened that we decided to try his advice and see what we could do with our own tool, not just in using it to build up the tool more, which is something we've done a lot of. Stephen talked about how the capabilities of Mathematica are feeding on themselves and making it possible to develop it at an ever more rapid pace. And not just to create interesting demonstrations of things that we would like other people to do if they were to buy our tool, which we do lots of, but actually do something ourselves using the tool. And there's sort of two examples, I think, of that really stand out. They're not the only ones. There's other things that have been done. But Wolfram Alpha is, of course, the ultimate killer app for Mathematica in a lot of ways. Mathematica is this hugely complicated system for solving general problems. And one of the difficulties with selling it to people is that nobody has a general problem. People only have specific problems. And it's a little bit hard to wrap your head around the idea of a tool which isn't focused on solving your problem. It's focused on solving all problems. And Wolfram Alpha is a great example of where you might want to solve all problems simultaneously and need sort of a tool that is optimized for doing that. And then a second example of this sort of eat your own dog food philosophy is touch press, which is a more recent and perhaps somewhat smaller scale spin-off dedicated to the idea of, so I'm not going to actually talk much about Wolfram Alpha, since you'll hear plenty about that. So touch press is a small ebook publisher that is trying to sort of explore the question of what should ebooks be. This is a question that has been explored over time. I think there's people here who've been doing it since the 60s, done in the 70s, was done in the 80s. There was a big flowering in the 90s of interactive media. People made electronic books. I made my first electronic book in 1992. Nobody cared, except possibly some people in this room. I thought it was pretty neat, but it didn't kind of catch. The world wasn't ready yet. But the world is ready now. And so what I've been spending my time almost exclusively on for the last couple of years, or a year and a half, is sort of seeing if it's possible to be an ebook publisher, inventing kind of what should books be in the context of all these new devices that people actually want to read books on. So that's what I've been doing. And I just got these pictures whipped over from London this morning, because I realized we should show people just exactly what is touch press. It's based mostly in London. We have a few employees here. I'm still living in Illinois. Maybe a dozen altogether in London. We have our CTO, who I'm sure is, yes, right here, John Cromie, right there, who lives in some kind of tiny village in Ireland that last time we tried, even FedEx couldn't find it. But apparently there's some bigger town nearby that you can tell them to go to the rock and turn left and right at the big oak tree or something. So other than that, it's basically a London-based outfit. It's very interesting to spend a little bit of time on the other side of the fence. I don't know how many of you caught this in Stephen's little demonstration of the first version, or one of the very first versions of Mathematica, starting up with, I'm very proud of the fact, my name there on the startup screen. It took a couple of years before Stephen realized that there was no startup screen for the kernel. And so my name was actually the only one that people saw when launching Mathematica on a Macintosh, which is not entirely fair. So after that, we had a startup screen for the kernel, too, where all of the very important people who worked on the kernel could also have their name on a startup screen. Anyway, so I'm now in the position of actually trying to use in a serious way the tool that I spent 20 years working on. And basically finding that in many cases I have only myself to blame for whatever it is that's not entirely right. But over time, we're developing more and more people that I can blame for that. I apologize in advance for those of you who come to this conference every year, because you will have heard a little bit already. I wanted to give just a bit of background for them, because I understand that there are, in fact, a bunch of people here who have not traditionally come to our conferences, which is great. So I want to give a little bit of background about touch press products, and then tell you about more new things that we've been doing over the past year. So the first product that we released was called the Elements, and it was released simultaneously with the iPad back in April of 2010, right. And because we wanted to release it simultaneously with the launch of the iPad, there was basically a 60-day period between the announcement of the iPad, where Steve Jobs got up and said, you know, once again I have delivered you from your boredom and created a device for you that you will need urgently to have 60 days from now when we release it. And so we had that 60-day period in which to, you know, invent a product, and because the thing that we invented was new and different, there were, of course, no tools for creating such a product. And one of the taglines that I've often, maybe not entirely seriously, suggested that we should use for Mathematica, rather than, you know, a system for doing mathematics by computer, or the world's most complete technical computing something or other, is a system for doing things for which there is no system for doing. Because that's really what distinguishes Mathematica from almost everything else in the world. I mean, pretty much everything else in the world. Is it, if you have some kind of a computational difficulty that, you know, you need a thing that will do something for you on a computer, and you don't have it, in a surprising number of cases, for a surprisingly wide class of things you might need to do, you can build that tool faster in Mathematica than anywhere else, provided, of course, that you're a good Mathematica user. So given only 60 days to create a tool to create a new kind of product, and given that it was me doing it, there was really no question that it was going to be Mathematica that was used to create that tool. And so we did that, and then we used that tool to create a product, and you know, we made various rash decisions along the way, like the fact that it needed to have a theme song, and that needed to have a very complicated video to go with it. So we had to build a tool to develop that video, which you saw earlier, the Japanese version of. We'll get to that in a minute. And then we had to invent a company to be the publisher of it, so that it wouldn't look like it was just, you know, out there with nobody responsible for it. So we invented Touch Press, which is a partnership between myself and Max Whitby, who's a film producer based in London, and Stephen Wolfram, and the Wolfram family of companies in various capacities. And we invented that company, and we published under the name. 6 or 8 months later, we actually incorporated the company and signed all the documents. But in the meantime, we were pretending there was a company called Touch Press. And so let me just give you a quick demo of what the Elements is, for those of you that haven't seen it. How many people have not seen the Elements, by the way? Well, some people haven't. So we'll do a really quick demo, just so you kind of have some context for what I'm talking about. So I've switched over. We're now broadcasting from this iPad, or projecting from it. This is the home page. This consists of a periodic table where everything is rotating. Mathematica was not involved in the actual photography of these objects. These are real objects that pictures have been taken of. There's no 3D modeling or anything. However, essentially everything else you see on this screen is processed through and output by Mathematica. So these are, you know, it's a QuickTime movie which was created by using Mathematica Code to assemble all of the little images taken from lots of much bigger images, scaled together, put together, output. If you touch one of these things, you get a bigger one. This, you know, again, every single thing on this page is generated by Mathematica. The actual bitmap images that you see are output from Mathematica. The data, obviously, is Wolfram Alpha data, or, well, it's actually Mathematica element data, but that's what underlies Wolfram Alpha. There is a Wolfram Alpha link, hopefully. Yes, so here we get you know, much more information. And look at that, the same picture. Isn't that interesting? and lots more detailed information pulled up from a very simple query to Wolfram Alpha. If you go on to the next page, you get, let me do that again. Watch closely how the objects appear on the page. You see they kind of zoom in and they rotate a little bit. So that's another QuickTime movie. It's masking the time it takes to load the objects underneath. That movie is generated completely by Mathematica. Every pixel of it is output from Mathematica based on a piece of code that, takes images, explodes them, scales them, adjusts them, changes the alpha values, puts them together. When the things land, they're then deployed as these kind of finger rotatable objects that you can spin. The files that underlie these are generated by a bunch of Mathematica code that's calling utilities and assembling binary things. The page layouts are all Mathematica. So just very quickly, you get the song. Actually, you probably can't hear it very well, but anyway, this is the English version of the song. The relevant thing here is not so much the music as the fact that
there's antimony, arsenic, aluminum, selenium, and hydrogen,
the video,
nitrogen, and rhenium, and nickel,
what a pain this would have been to try to do that video in some kind of video editing system. So instead, this is also Mathematica code. Somewhere deep in the bowels of that code, we're going to stop that. Somewhere deep in the bowels of that code is a little table that lists down to the millisecond the exact moment at which Tom Lehrer in 1959 recorded that particular name of that element, so that the code can then, start putting up the images of that element at the right moment. Okay, so moving along. And so I'm going to show you in a little more detail, if we don't run out of time, the actual tools that we used, not to create the elements, but to create some of our follow-on products, which use evolutions of those tools. So that was our first product. We have since released, depending on how you count, 6, 7, 8 different products. We've released Elements, Solar System, Gems, Dinosaurs, Wasteland, and 2 apps within a strange collaboration with Bjork called Biophilia. We've also released Japanese and German and French translations of the Elements, Japanese and German translations of Solar System, and hopefully soon additional translations of some of the other products. And most of these have 2 distinguishing features. One is they used Mathematica in some way in their production, I think with the exception of Wasteland. I think that's the only one that we actually didn't use it at all, unless John remembers something I don't. And all of them have been listed as App of the Week by Apple, which it blows my mind every time I think about it, because that's like the most Apple can do for you. And I attribute this largely not so much to the fact that we're doing something so amazing, but rather that the rest of the field in ebook publishing is filled with crap. And it's amazing. It's absolutely mind-boggling how much crap is out there. So you just have to go like a little bit above that, and they love you. Right, so Mathematica is a very important part of what we do. And let's, I'll go quickly show you, right, there we go, pictures of all of our apps, which we're going to now demo the first one of. Oh, good, we have Rumble. Yeah. So Solar System, first use of Mathematica is that, once again, this movie was generated in Mathematica, because what a pain it would be. Let me just show you a couple things. One of the innovations was 3D textures instead of just photographic rotations. So you can actually zoom in here. Integration of a lot more live action video than is in the Elements, which actually that reminds me of another thing that Mathematica was used in, which is, let's see, what is it, Deimos, right, is in the feeding, the production of the money needed to feed one of the performers. This is my daughter Emma, who's demonstrating that if you jump really hard on Deimos, you can jump into orbit. But since she's only on Earth, she doesn't get off the planet. Actually, we had an extended controversy about the question of, you can jump off Deimos, there's no question about that, but the question is, can you jump off Deimos onto Mars? like, could you do that as an extreme sport of the future and parachute down to Mars? And I think the conclusion, after much consultation with the experts at Wolfram and other astronomers and such, is that you can't do it, because you can jump out of the gravitational field of Deimos, but you can't lower your orbit. You know, the amount of velocity you would need to actually jump out of orbit is way, way beyond what a jump could do. Anyway, that's neither here nor there. Next thing we did was GEMS. So GEMS is actually, let me go to the home page. Yeah, you know, it's also sound. We working with a company whose specialty is product sound. So like if you get a fancy sports car, all the little beeps and pings and warning things and all that, they're a company that design and give you nice, pleasing constellations of sounds. And so they've generated, you know, given us soundscapes with you know, when you touch something, you get nice little pings and things. Assume you can hear those. This is a product which is basically exactly along the lines of the Elements. It's the same production system except evolved some, the same photographic system. Couple of nice improvements, like here you could zoom, which you couldn't do in the Elements until we released the update. There's a life size button here, which is pretty cool. You hold that down and everything becomes the actual size that it is, which of course we can only do because it's an iPad. It's a device of known physical size. And of course it's not right on the screen, but on this actual device, which is kind of cool, that it's, you don't normally have this knowledge about the screen that your software is deployed on. We know exactly how big it is, so we can actually show you exactly how big these objects are. Many of them are very small. So let me now actually show you, let's see if I, so this is a relatively elaborate piece of Mathematica code that is sort of an evolution of what I built originally in about 2 weeks for the Elements. It actually was, it looked more complicated for the Elements. With time, one can simplify things a little bit. But basically all the features were there after 2 weeks of work. This is just kind of the other 90% of the work. So, you know, the challenge here is that we need to have a book. It's hundreds of pages long. It has many hundreds of objects in it. And we need to be able to do a page layout, which ultimately doesn't translate into an image, but rather translates into a bunch of configuration files that can be used to deploy these finger rotatable objects on the target device, those are XML files calledplists, which contain, you know, listing of this object, you know, this file at this position with this scaling, this piece of text should go there. You know, it's like a sort of HTML-like layout, except something understood by our runtime system. At the same time, the positions and identities of all these objects need to be known to Mathematica Code, which can then generate, for example, the spin-down movies. So, you know, we really need to have our own editor environment. This works just like, whoops, what did I do? Oh, I selected a different page. Let's go to some gold page. It works just like a page layout system that you might expect. You can move things around, you can resize. You know, this handle moves the text. This moves just the text. It's got all kinds of little features. It has a checkbox for life size, which now, in this mode, you can move things around, but you can't resize them because their sizes are determined by a database somewhere that knows how big the things actually are. Another variation or sort of problem that you don't have with a typical page layout system is that these objects are not just, I'm trying to find one that has a good example of that. Oh, how about Sapphire? Yeah, so these objects don't just exist this way on the page, they can be rotated. And so we want to have a mode where we can show, this shows sort of the composite extent of these objects at all possible rotational positions. And you know, we don't necessarily avoid all collisions, but you kind of want to take that into account. So I mean, this is an example where I have absolutely no idea how else you would do this other than using Mathematica. I mean, it's probably possible to make a tool this flexible in 2 weeks using some other system, but I don't know what it is. Anyway, so that's that. Okay, well, actually, now we're going to switch back to the one product that really has nothing to do with Mathematica, but it's really cool. So this is The Wasteland, the poem by T.S. Eliot, which nobody understands, that makes it, that's the property that makes it particularly suitable to presentation in electronic form, because nobody understands it, and so you want to learn more about it. You want to see, what do these words actually mean? So you can read here. You can get notes, touch any line, and it'll explain to you, what do these lines actually mean, almost word by word in some cases, with extensive commentary there. You can get it read by...
What are the roots that clutch? What branches grow out of this stony rubbish?
Apparently not good at reading his own poems.
You cannot say or guess.
Alec Guinness, who does a little bit better job.
You cannot say or guess, for you know
Viggo
only
Mortensen,
a
who I
heap
didn't even
of
recognize
broken...
that name, but apparently, apparently he's some kind of a
broken
star.
images where the sun beats and the dead tree gives
we
no
just
shelter,
wanted somebody with an American
the cricket
accent,
no relief,
and he was
and the
available.
dry stone no sound of water.
But by far the
Only
most
there is shadow.
amazing
There
thing
is
is
shadow under this
this
red rock.
performance
Come
by
in.
Fiona Shaw, otherwise
Under
known
the
as
shadow
Aunt
of this
Petunia
red
in the
rock.
Harry Potter
And
movies.
I will show you something different from either your shadow at morning striding behind you, or your shadow at evening
watch the performance,
rising to meet you.
or
I will
you
show
can,
you fear
move
in
through
a
here and,
handful of dust. And
touch
drank
any
coffee
line
and
it will
talked
immediately
for an
go to
hour.
that place in the
Bin
performance.
gar keine Russischstam, aus der Teuen, echt Deutsch. And
Or
when we were
full
children, staying at the Archduke's, my cousins.
So this kind of demonstrates one of the other strengths of Touch Press, which is Max's deep background in television production, to be able to create this amount of really high quality visual media. Next, and we're going really fast here because we don't have that much time. March of the Dinosaurs. This one was distinguished by the fact that I think it was the first time that somebody other than me at the company actually used Mathematica to do something interesting. So, although that may not be true, John may have done something probably beforehand, but this was like a guy just off the street, and I managed to get him to write a piece of Mathematica code that worked. So this is it's a children's book of dinosaurs, and you start at the beginning. Come on. And we've got some guy who was on, an actor who was on Doctor Who, which just impresses the hell out of my children, to narrate it.
High summer in the Arctic, 70 million years ago. The midnight sun shines down.
But the relevant thing to notice here is these little things along the bottom. This sort of navigation bar. There's different dinosaurs that appear. Whoever's in the story page, let's find one with more than one. Yeah, they get little stones that appear that represent each of the different dinosaurs that appear in that page. And if you touch one, you get a nice. These guys, you can, instead of just rotating, you can actually grab them. Little bits of video. So let me show you the piece of code that. It's it looks a little bit like the kind of code, the kind of Mathematica code that people who have not completely gotten the functional programming style yet tend to write. But it's very workmanlike, it's very nice. And what's really cool about it is the end result. So first of all, you notice this parallel enabled. I admit this is a little piece of code that I actually gave him, but, sorry. Basically, I just said, if all those map commands there, if you just replace them with parallel map, it's going to run a lot faster. And sure enough, without touching his code, it now, it goes a lot faster because it's able to run on multiple processes simultaneously on some multi-core computer. And what it produces as output is this. So the output of the Mathematica code is these beautiful images. obviously working from some raw sources. But this is a nice little example of something that, of course, you could do this in 10 different ways. You could just do it in Photoshop or whatever. But it would be a pain in the butt, and it's faster to do it this way. And it's also, I think importantly, more flexible in that if this had been done by hand, then when someday we need to do this for an Android device or something like that with a slightly different aspect ratio or whatever, we're potentially going to be really happy that as much of this process as possible is automated. So that's that. So now we're into upcoming things. And let me show you my favorite upcoming thing, which is skulls. So I'm going to show you first not the actual app, but rather sort of a review thing. This is a little utility we have for creating previews of photography that we've done. So there's many pages. I think there's 7 pages like this, almost 400 objects altogether, a combination of actual skulls, and let's see if we go here, pick one, I don't know, something like that. So these, just as in the elements, this is again, at this level the technology is very much the same as the elements, although refined. And you can see these things, you can zoom in. So let me show you actually one of probably the most complicated piece of Mathematica Code that we have for use in this production process. The problem was that we were doing this in England. We normally do this in the US, and we had a set of light bulbs in England. It turns out they flickered. They had a subtle oscillation in brightness, which becomes extremely apparent if you look at, I think this one. So this is a plot of the average brightness, and you can see there's a wiggle. And if you look at the image just animating down below, I don't know if you can see it in the projector, but it's flickering. It's like, wow, that is really bad. And so what was needed was, if I, let's see. So this is the original brightness profile of this rotation. Very helpfly, there's people at Wolfram Research who really understand math, way beyond my abilities. In particular, they understand wavelet analysis. And so I got a piece of code which allowed me to have this slider that beautifully removes the ripple. It's amazing. And what it's doing is it's like a sort of how many terms of the wavelet series do you take? And if you just cut off terms until the last obviously wrong ripple disappears, you now have the desired profile of brightness. And there's subtle issues, like for example this first one here. You see there's this little thing here, like what's going on? That's why I added the preview, because it turns out, if you go back and click here, that's when the beat crosses the front, and that's not an artifact. That's actually meant to be there. So it's important. And then there's another problem that happens every once in a while. It turns out there was a feature of the camera that we were not aware of. You see the little red dot there? Where every once in a while, if you didn't turn this feature off, like 1 out of every 2,000 shots, it would decide that you were wrong about the exposure and fix it for you, which is really annoying when you just really don't want that. And that would produce spikes, typically only 1 every several rotations. There would be a frame that's just way off. And so, so again, there's Mathematica Code that detects those spikes, and there's an adjustment for the threshold. And so now we have a target brightness, and it then makes up a brightness by interpolating around that bad spot. So now we've got a bunch of images that are wrong brightness. And it turns out you can't just calculate, this is the brightness of the image on average, this is the desired brightness, let's apply a correction, because the sort of quantization of the 256 levels causes you to end up with a brightness that's not quite right if you do that. So it's actually, then it does Newton's method shooting to find a parameter to the image brightness command to result in an image that has as close as possible to the target brightness, which makes it slow, but try to do that somewhere else. So the result of that then is a set of instructions to a piece of code that runs for a very long time, processes all these things, and produces a new set of images that are cropped down and brightness corrected. And if you look at this last one, if we go through here, it flickers a lot less. Now actually it's not completely gone. There's still some flicker visible because it turns out that different bulbs flickered by different amounts. So it's not actually possible to completely remove. And where those spikes are, actually, I ended up having to do histogram matching to try to, coerce the histogram of one image to match the others around it to make that flicker as minimal as possible. The main result of this is that we now have very strict rules about testing the lights before doing too many rotations with them, because this was really kind of a pain. But it worked, and it was an excellent opportunity to do some fairly sophisticated math type stuff with Mathematica. Yes, and by the way, I should say that it's Nick who is largely responsible for how beautiful these things look, the gems and the skulls and everything. That's basically high-class photography work, not Mathematica work. So Stereoscope, this is a product that is a little farther along the pipeline. It's a book about stereo photography. And an issue there was, rather than just presenting the images side by side so you could see a stereo image, could we do something more interesting, like let you zoom in? And the 3D experts that were working on this and that were very familiar with 3D viewing software couldn't think of any example where you have a 3D viewer where you can pinch zoom in simultaneously two views. And we really didn't know if that was going to work or not, if your eyes would just explode or something if you tried to do that. And rather than trying to write a piece of C code or something to do this, I just wrote this little piece of Mathematica code and say yes. And so this creates a little manipulate where we have, for those of you that can do this without glasses, that should look 3D. And I promise you your eyes will not explode, because it turns out this actually works rather nicely. You can zoom in and you move around, and the 3D effect remains effective even as you zoom in and out. So as a result of that, we now know that this is a reasonable thing to do. We won't use Mathematica to actually deploy this in the final device, but but this proves that it's a worthwhile thing to do. And I think we've actually already implemented this in C code, I believe. Yeah, so we actually have it in C code now. The actual product is still a ways off, but we wouldn't have done the C code. We wouldn't have thought it worthwhile to do that effort if we hadn't seen the prototype in Mathematica first. Okay, so one other thing we use Mathematica for is basically counting the money, because Apple's reporting of revenue is extremely confusing, and there's commercial tools for understanding it which get things wrong, just wrong. So of course we have a Mathematica tool. This is a chart of sales of the elements from inception with various things like Christmas is good. I have no idea what that is. I think we released some other products and it gave a little spike to the elements. So anyway, that's sort of another thing that we do with Mathematica. So thank you very much.